Hi, in this video, I'm going to walk you through problem 16 in chapter 5. I consider this problem as the most challenging in homework 3. First, let's read the problem. Okay, so at this point, you probably recognize this problem is a production scheduling problem, very much like the example we went through in class, with some minor changes. So there are demand for 4 months. There are ways to meet the demand. Regular production, which is most economical, $100 per windshield, up to 100 windshields. Overtime, up to 50 windshields at a cost of $130. And also purchase from a competitor at the cost of $150, no more than $450 over the 4 months. Another way to fulfill demand is from on-hand inventory. However, there's an inventory carrying cost $10 per windshield per month. Just ignore the hints over here. We can just follow the logic or the structure from the production scheduling problem we did in class. So first step coming to this type of problem as a novice is to recognize what type of problem it is. So this is a multiple period production problems. So the difficulty part of this problem is to find out the logical relationships between months. First of all, we know that the problem is to find a production plan to minimize the cost over the 4 months. So list all the facts in this table. So we're going to list the beginning inventory, regular production time, how much to produce using overtime, and how many units to purchase in each month, and then ending inventory. Those are the decision variables. Month 1, beginning inventory is 40. Suppose you produce R1, overtime produce O1, and the P1 represents how much to buy from competitor, and I1 is the inventory left over, and the D1 is the demand that must be met. Okay, so over here I put the facts of capacity and the restrictions, how many windshields can be bought over the 4 months. It's a demand information. So first of all, the capacity constraint must be met. The regular production should be less than equal 100 for all 4 months, and the overtime production must be less than 150. So this I equal 1, 2, 3, 4, right? And then the sum of the purchasing should be less than 450. The next important logical relationships among the decision variables are the balance. Flow in should be greater than or equal flow out. Okay. I remind you in class that in order to set up Excel spreadsheet correctly, the right-hand side of all the constraints must be constant. If you look at the month 1, 40 initial inventory, plus what is produced using regular time, plus the units producing overtime, plus the units purchased from competitor, minus what you want to carry over to next month, and that is net supply that you can meet the demand. So must be greater than or equal to demand. So the same thing you can do month 2. So the end of inventory of month 1 equal the beginning of inventory month 2. So the total supply of a month 2 is I1 plus R2 plus O2 plus P2 minus you want to carry over to next period, it's I2. This should be greater than or equal 140. So the same thing, you can do this for month 3 and month 4, and then plus non-negative constraint. So looks good. At this point, you're ready to set up Excel spreadsheet. You also can borrow this structure to make Excel spreadsheet clean and elegant. So let's look at the Excel spreadsheet I set up. Okay, so the structure is pretty much like the sketch of the formulation. And the beginning inventory, production regular. The decision variables are in this rectangular area, indicated in color green. And then in order to set up Excel software parameters, you need to have the left hand and the right hand side. The flow balance is here. This one is a total supply, in month 1 net supply. So you're adding the inventory plus production plus purchase minus what you want to carry over. That's in B8. That's going to be greater than or equal to the demand. Okay, so this is the flow balance. And then over here, the left-hand side is the production quantity, overtime production quantity. All 4 months should be less than or equal to the capacity. And the purchasing is the total purchasing of the 4 months. So it's a sum of cell B7 to D7 should be less than or equal the upper limit 450. For Excel, you also need to have objective function value. There are many ways to do it. So, the best way is to show more details, right? If you know the decision variables, you will know the cost of each category. So the expression is going to be the regular production quantity, B5, the decision, multiplied by the unit cost. So once you get this set up, you can use this to copy all other cells, and then that's it, right? So the spreadsheet is set. The last step you need to do is to set up a Excel software, get a software to generate a solution. Okay, let me close this one, and then just pretend it's not solved yet. So just put all 0. Okay, so let's look at software. That's objective. By changing the variables or the decision variables from B5 to E8. Okay, so one thing you need to pay attention here is you cannot include the beginning inventory if you have included any inventory decision variables. Okay, and then beginning inventory is a given, you cannot change. So the decision variables just from B5 to E8. And then the constraint here is the regular production. Constraint less than or equal 100, where you put cell H5. The overtime should be less than or equal this one, 50. And over here, you can do it one shot. Is the total supply over here gonna be greater than or equal the demand? You'll put in B11 to E11, and then let's close the software first. So this is the sum of the purchasing. Okay, so now you're ready to do it. It's the F7 should be less than or equal H7, and then non-negative constraint. At this point, solve, generate solutions, and it tells you one thing you need to pay attention for setting up a Excel spreadsheet is the right-hand side must be constant. All the expressions that involve decision variables has to go to the left-hand side. Okay, if you don't do it, Excel will generate some pseudo solution, and then if you look at it, some of the constraints will be violated. So very important to know. That's it for this problem.